Section 8.3, write the formula for geometric sequence. Find the seventh term in the geometric sequence. So first we have to find the ratio between these two numbers, and the way we do that is we take the second number, right, and then we divide it by the previous number. And that in this case gives us 1/4 after simplifying, after dividing both these by 16. Now we can verify this. We can do another couple in the sequence, right? So we could do, well, let's say we have a 4 divided by 16, and sure enough, when we simplify, we get 1/4 again. So this just verifies it twice. That in this case, our ratio is a 1/4. Okay, so what we're going to do is we need to plug this into the general formula for this, which is the first term multiplied by the ratio to the n minus 1 power. So if we're trying to find the seventh term, we have to put in the first one of the sequence right here, in the first one of the sequence. So that must be a1 is equal to 64. a1 is 64. It's the first one in the sequence. Multiplied by r, which is 1/4, to the n, which is 7 minus 1. Okay, so that's 64 times 1/4 to the 7 minus 1, which is a 6, which means 64 times 1 to the 6th power over 4 to the 6th power, which is 64 to the 1 over. The 4 to the 6th power is the same as 2 to the 12th power, 4,096. 4,096, which would be 64 over 4,096, which you could divide, I think both of those are divisible by 64. 64. So this should give you about a 64. 1 over 64. So it should be 1/64. Find the indicated sum. Use the formula for the geometric sequence. Okay. So what they're saying is they want you to start at 1. They want you to end at 9. And this right here is your geometric sequence. Okay. So the 2 must be your ratio. So in this case, r is equal to 2. And your first term, if I plug in there, I can find my first term. So my first term is 3 times 2 to the first power, which is 3 times 2, which is 6. So my first term is 6. We have our ratio, and we have the first term. Now the general formula that we have for this is S in the sum of the first nth terms is the first term multiplied by 1 minus r to the n being the last term, the number of terms, 1 minus r over 1 minus r. So we have our first term, we have our r, we have our n, we have all the little pieces, so now we plug it in. First term is 6. 6 times 1 minus r being 2. And that is to the nth power, which in this case is going to be 9. So n is 9. So n is 9. So we'll plug a 9 in there right there. And then 1 minus r, which again is 2. So what we do is 6 times 1 minus 2 to the 9th power is 512. And 1 minus 2 is negative 1. 6 times 1 minus 512 is negative 511 over negative 1. 6 times negative 511 is negative 3066 over negative 1, which gives me a positive 3066. A job pays a salary of $24,000 for the first year. During the next 19 years, the salary increases by 9% each year. What is the total lifetime salary over a 20-year period? Our initial is going to be 24,000. Our ratio is going to be 1 plus 0.05, or 1.05. N is going to be 20-year period. We want to know the total lifetime salary, so it's going to be a sum. The sum is the first term multiplied by 1 minus the ratio r to the n power all over 1 minus r. The first term is 24,000. We multiply by 1 minus r. R is 1.05. N is 20. All over 1 minus 1.05. That gives me $793,582 and rounds off to 90 cents. Now they asked us for the nearest dollar, so because the ones is the dollar place, and to the right we have to look at that. Since it's a 9, if it was 5, 6, 7, 8, 9, we have to round up. So that 2 is going to turn into, so this is approximately 793,582. But instead of a 2, we're going to increase it by 1, we're going to make it a 3. So $793,583.